All right, take it away.
Well, all right. Thanks, everyone, for joining. So let me briefly introduce myself. I'm Wim. I'm a data scientist at Cmotions. I'm a consultant, so practically day-to-day job helping building machine learning models and busy with a lot of Python. And I was asked to give a presentation here about data exploration in Python. So the idea of this workshop was mainly to give you guys a feeling and play around yourself with Python to experience and learn how to do things. And although we have a pretty large group, please feel free to ask any questions you have during the session, because I like to have some interaction in this session. So first, in order to get started, you guys should also be able to run Python and try out some code. And in order to do that, I would like to ask, if you do not have a Google account, please create one for this session, because we're going to work with Google Colab and put some files on a Google Drive that we can use for this workshop. So if you don't have, please quickly make one. I also put a zip file in the chat, so everybody can download that. And then let me share my screen. So everybody can see my screen right now?
Yes, we can.
Oh, that's great. So what I would like you to do is I just put the zip file with all the files we need in the chat. You can download that and then unzip it, and then you have a package here called ABW Python Data Science 1. And what I would like you to do is go to your drive, go to My Drive, right-click here, and click upload a map. Then you can select your folder, and by doing so, you put all your files in your drive. So please do that right now. Then if everybody has that, we can proceed.
Just a second.
So everybody got that, or still busy?
Could you repeat what is to be done after downloading the file?
Yeah, so when we have the file here, go to your Google Drive, My Drive, and what you can do here is right-click and say upload a map, or directory, maybe in English. So not a file, but a directory, and then you can select the map I shared with you, such that in your drive you will be having the ABW Python Data Science 1 project.
Yeah, it's called folder in English. That's the English word for everyone. And if everyone can just raise their hand when they're ready, when they've finished doing that step, then once we have most everyone's hands raised, we'll go on. The file is in the chat.
Yeah.
I've also uploaded it to GitHub, to the Python folder. You've joined late, you might not see it, so you can also check on the GitHub folder.
Yeah, if
I can also
I see-
reshare it here.
I don't see a lot of people, but the ones I do all have their hands raised. So
Yeah, we
oh,
have 12, 13 people, 15. Yeah,
okay.
let's wait one more minute for everyone to get on the same page.
I joined now. What is the instruction?
So the instruction is I shared a file in the chat, and you need to unzip that such that you get this folder, a directory, ABW Python Data Science 1. And the instruction is to go to your Google Drive and right-click within your drive, and then upload folder. And then select the folder I shared.
And once you've finished doing that, if you can raise your hand in the chat.
So most of everybody got it.
24 people have raised their hand.
Some out of
59.
59. Let's wait then for a couple minutes.
Yeah, so if you've done this, can you raise your hand? So not in the chat, just raise the hand, and that will let me know that you've completed it.
Sorry, I have uploaded it to iDrive, but I cannot see it from the collab interface. I cannot see the folder.
You should see it in my drive.
No, I see it there, but I don't see it in the collab Google
Yeah.
collab.
Yeah, we're going to get there.
Okay, that's okay.
That's going to be the next step.
Is it possible to link it to a GitHub repository? Then we can all work in the same place.
Well, yeah, I think because well, the easiest thing is to just upload it in my drive, and if you have the file here, then we can start working on it via Google Colab.
Okay.
So most of the people got it.
Yeah, I think let's go ahead. There might be some people that are still joining. I'll also share the instructions in the chat for those others, but everyone can lower their hand now.
All right, great. So the next step in order to write some Python is we would like to open the folder we just uploaded. And what we see here is this file, data loading and exploring.ipynb. And what we want to do is right-click it and then open with. And what you can do is click on open with other apps. So if we click that, then what we can do is search for Colab, and then you get Collaboratory, click it, and you can click on Collaboratory. Then if you haven't already, it will ask if you can install this, and then it will be installed. Won't take more than a minute. And if you have installed that, then you can open it with Google Colab. And if you click this, you will open this file and you will get to Google Colab, and you will see the notebook here. So please do that steps. So right click on this, open with, and then Google Colab. If you haven't installed it already, you can click here for opening more apps. And then search for Colab. So yeah, if you're finished with this, please raise your hand again. Then we know when we can continue.
Can you go over it once more?
Yeah. So we were in my drive.
Please, can you go over
Sorry,
it once
Vim,
more?
there's a, sorry, I accidentally muted you because there was some background noise. Could you unmute yourself again?
Yeah, so
That's better, yep. Hold on one second. Okay, now you can go ahead.
yeah. So here we have the folder we just uploaded in my drive, and we can open it, go to the data loading and exploring file, right click on it, and then say open with, and try to open it with Google Colab. But if you haven't installed it yet, you should go to more apps, and in more apps you can search here for Colab, and then what you see here is Collaboratory from Google, and you can click it and install it if you haven't, but then just continue clicking it, and then what you will get is that you will go to collabresearch.google.com with the right file opened.
Looks like everyone is there.
Yeah?
Yep.
All right. Well, then finally...
Everyone can lower their hands again. Sorry,
yeah.
Go ahead.
So that's great. That means that we can start working on our Python skills. So yeah, let me enlarge my screen a bit more. So now, in this workshop, we'll be talking about data loading and exploring. So we're going to talk about what's a data frame in Python, loading CSV files, subsetting data frames, conditional subsetting, also some summarizing and aggregating data sets. And in the end, we're also going to give an example of how to make plots using Python. But in order to get started, we first will be needing some packages. Packages in Python are useful because they are pre-programmed Python scripts, which we can use in order to do things. And for this session, we're going to need NumPy and Pandas, which are libraries based on created for data frames. And what we are going to need to do is to also connect with Google with our drive. So we just inserted the file that I shared with you on the My Drive. And what we are going to do is to use the Google library to import the drive. And then what we are going to do is mount the drive. And we can just run these steps. And what it will do is now connect with our drive. I've already mounted it, so there's no need for it if you run it again. But then, what we did is we just connected with Google, and well, let me load this again. Because I think we're in a different file. So yeah, let's connect. Let's see why it's not working. Ah. Oh, all right. I don't know why it doesn't work, but yeah, if you run this for the first time, what you will get is you just connected with the drive, and what we want to do is we want to change our working directory to the file we just uploaded. So what does that mean? Python works from a certain directory in your computer, or now the drive, because we are connected to it. And what we want to do is we want Python to know that if we want to read files, like our data file, then we want it to know that it's got to be in the right folder. So within my drive, we just uploaded the folder ABW Python Data Science 1. And what we can do is to change our directory to set the right directory for this session. And then what we can do is find out if it worked and look at our current working directory. And then what it says is we are in the right directory, so we can start using our files that we just uploaded. So that's going to be the first step. And now what I would like you to do is, well, do the same. So please, in your notebook that you just opened in Google Colab, please import the packages needed, which you can see on top, and then mount Google Drive and set your working directory. So let's take 5 minutes for that.
Sorry, Vim, can you repeat the instructions?
Yeah, so the assignment is, just as I explained, that what we first need to do is we need to import some packages, mount our drive, just like the example above. And then what we would like to do is to here change our directory to the right folder. So if you run all these steps.
Someone in the chat is asking, is anyone getting a file not found error?
Yeah, if you have the file not found error, but you did get connected, then please go check out your drive. Because if it is in my drive right here, then it should be there.
Someone is getting an error. The file has been corrupted or is not a valid notebook file.
That's weird. Maybe try to download the file again. Make a new copy.
Melanie is asking, should we be completing these steps in the notebook, but in a new notebook?
No, in the notebook that you have opened. So you can do everything in the Colab. So please don't make a new one, because yeah, it's useful that you can run the steps ahead, and you can just continue working in it.
Carla asks, did you make sure you are working in the right directory?
Sorry, that question was meant for my teammates.
Okay.
Yeah.
Yeah,
So you can check if you have it in My Drive, because it can also be that you have put the folder inside another folder, and what you then need to do is change your directory. So for example, you can put here directory and then where you put it. But the file needs to be in My Drive here. Yes, if you have done this and it worked, then please raise your hand again so we can see how many people got it.
One question from Shola, why did we import quote OS quote?
Yeah, OS is a typical library to use your system operations to functionality. So mainly what you can do it with Python is, for example, look at the directory you're working from, or check out the files within a folder. So it's just to engage on your system where Python is run. So and because we want to change our working directory, and that's the folder we will be working from with Python, we import OS such that we can change the folder to the directory from with the right files in it, and then we can look at if it is the right working directory that we have. And what we can then do is see indeed that we are working from the right directory. Yeah, is that clear?
Yep. Valeria has
መከታተል
a
ስለማልችል ቪዲዮውን ስሰማ ነው የሚሻለኝ።
Valeria posted in the chat, she's getting a error file not found, trace back most recent call last. She copied the information in the chat. I'm not sure if you're able to see that, Vim.
Yeah, I can see the chat. So if you successfully run the drive.mount,
There's some background noise. Can everyone make sure they're on mute?
well, yeah, so if you successfully mounted your drive, then you should definitely be able to do this. Or if you get the error file not found, then you did not upload the directory in your Google Drive. So please make sure you did get uploaded the file correctly.
There's a question. What is os.getCwd parentheses for?
So the OS library is for to use functionalities for the system operations. So what you can do is call out functions to, for example, look at the current working directory, so where Python is running from. And what we do with os.getCwd with the brackets, then we say, give me the current working directory, and then it will here print the working directory where we are working from. So yeah, that's we can see that we are working from my drive and the ABW Python Data Science one. So we are in the right folder, and we can start using this. So on how many hands are we currently at?
We're at 22. I think we can move on.
Yeah.
Everyone
Okay.
can lower their hand.
Yes. So please, if you did not, please try to make it happen, and else you can just also try to follow it without running the script. So yeah, we did it. This was actually just going through these steps and just run these, and then we must get the same result. And now we can begin with the fun part. So Pandas data frames. So if you want to work with data in Python, then you're mostly going to use Pandas. So Pandas is a package that offer a lot of functionality around data manipulation, and it also offers a Python object which is called data frame, and with that we can use the different functionalities to filter out our data frame or data objects. We can analyze them. So if we look at a Pandas data frame, it is actually similar to what you're used to when you look at, for example, an Excel worksheet. So the Pandas data frame is called the whole object. But within the Pandas data frame, we have columns, we have rows, and we have index to label them. So in Python, everything is an object, which means that every entity contains metadata or attributes, which essentially is functionality. So because it's an object, we can use certain functionalities on that. And in order to get a feeling on how we can do that, is by pressing or typing in a dot and then pressing tab on our object, and then Google Colab will show you a lot of possibilities that you can choose from. So an example would be we loaded our Pandas library as the name PD. So now what we can do is pd.read.csv. What it does is it will take a CSV file from the directory data / and then the file name smalldata.csv. We can set a separator and a decimal point. And if we run this, what we then get is that we just loaded our data. So Pandas has a lot of functionality. So what I just explained, if we type in PD, so Pandas, which is our Pandas object, we can fill in a dot. And then if we go to press a tab, well, then it's loading. And here we have a lot of things we can choose from. So for example, read CSV, but also what you can do is read in Excel or read Parquet. So there are many possibilities with this Pandas object. For you guys, if you also would like to try this, please make sure you go to Tools and then Settings and go to editor and then switch off code completion automation, because else you won't be able to do the tab trick. So that's make sure you got that if you want to try that. But once we have loaded our pandas data frame, we can now see that we printed our data object, and which is just a pandas data frame where we have country, abbreviation, and then an X and a Y variable, which are numbers. But sometimes we work with really large data sets. Now in this example, the data that we just loaded is very small, but if it is very big, it can be handy to only want to look at the top rows to get an idea of what the data looks like. So now that we have made our data frame object, our data frame object also has functionalities. So in a similar way, like with the PD read, we can also put a dot behind our pandas data frame. And then also we have certain functions that we can use. And one of the functions is head. So what this does is it will print the first 5 rows or return the first 5 rows of your data frame, such that you can have an idea about how many, what the data is looking like. The default is 5 rows. However, you can also adjust it by applying a number within the brackets. So if you want to, for example, get the top 10 rows, you can just put a 10 here, and then you can just see the difference that here it will print up to 10 rows instead of 5. Similar to the top rows, we can also use tail to get a feeling on the bottom rows, so the rows that are lowest. So if we, instead of head, use the word tail and we run it, then instead of the top rows, we get the bottom rows. Also, this has a default of 5 rows, and we can also play around with it. But the main idea is that's the opposite of the head. In order to, we were talking about pandas object, a data frame. So yeah, to get an idea and test if it really is a data frame, we can use a type function. It's a built-in function of Python that shows you what kind of object it is and what type of it is. And what we see is if we look at the type of the data that we loaded, then we see that it is a pandas data frame object. So indeed, it is the right object, and we can start playing around with it. So now, for you, an assignment to also load the dataset small-data.csv, and please make use of the above code. Then we have some different questions like print the first 7 rows using the head function, the last 2 with tail, find out how to get the shape of a data frame, print the number of rows in the data frame, and what parameters can you use in the function pd_read_CSV. So please try that out, and let's take 15 minutes for that.
When we print the data frame, how do we recognize that the first row is the title row?
Sorry, can you repeat that? So the first row is the title row?
When we print the data frame, how do we recognize that the first row is the title row?
So in Pandas data frame, you have you can set columns and index. So if you look at this, so the first row, so the columns, isn't actually part of the data that you use. So Python will recognize it as really the columns instead of the data. And if you read your CSV file, it will automatically set the first row in your CSV file as the column row. Does that give you an answer?
Yeah, I think so. Can you please repeat the instructions on the settings?
On the settings?
Yeah.
Oh, yeah. So if you want to play around with the tab and to see what functionality an object has, go to Tools, Settings, then Editor, and then you have code completion, automatic activation, and you want to switch that off and then save it.
Thank you. How long did you say they have?
15 minutes.
Is it an idea that I put them into breakout rooms so that they can maybe collaborate
Yeah.
together?
Yeah, that's all right.
Okay. What do you think a good size is for the groups? 5 people?
Yeah, 5 is fine.
Okay. So I'm going to put you guys into breakout rooms so that you can also support each other. If you have questions, you can always put them in the chat and always come back to the main room if you're lost. A question in the chat, Vim. Am I pronouncing your name properly?
Yeah, yeah.
Okay, Vim. Okay. Do we have to write the codes in the assignment?
Yeah, so you to play around and try it yourself, you can just put your code, try out your code in the assignments and try to get the answers. think we can close the rooms in a minute.
Okay. I just closed the room, so everyone will be back in 55 seconds or less.
All right. Is everyone back? Or not yet?
Yes. No.
Yeah.
Yeah.
All right. Well, then I hope you guys managed to get all answers. But luckily, below I also put the answers in the notebook, such that you can also find them yourself. Also after this session, if you want to play around and look into it more. But yeah, the first two questions, I think they were yeah, pretty easy, as they were also given as an example. So the first rows, if we want to get the top 7 rows, we can use the head function of our pandas data frame, and then set n is equal to 7 in order to get the top 7 rows. And in a similar way, we can use the tail function to set the n is 2 to get the top, the lowest 2 points in our data frame. Where it gets a bit more tricky is, because this is a new thing, is data shape. So if we want to know what size our data frame is, so if we want to know how many rows and how many columns there are in our data frame, what we can use is shape. And what we then get is we can see that our data frame has 9 rows and 4 columns, such that we get an idea how large our data frame is. If we are only interested in the amount of rows, what we can do is take the first number here, but what we can also do is to use the len function, which gives the length of an object. And for a data frame, that will be the amount of rows it contains, and therefore will be noun. In a similar way, what we can do is take the first of the index of our data shape, which is then also similar. I also see a question, how was the data named? Data/small data.csv. I did that. So I just used a small data set, created a folder, and then put it there. So that's why you could read it from your Google Drive. Then the last question of the assignments is how to get an idea of all the parameters that you can use. Well, what you can do is in Google Colab, you can fill in pd dot and then the function without brackets, and then put a question mark behind it. And then what you will get is a help file. And here it contains a lot of information about the function, but also all the parameters that you can use. So yeah, for example, the delimiter, we use that, the separator, those are all parameters that we can insert in our function to help out read a data set. So if you ever don't know what you can use within a function, you can just put a question mark behind it, and then there's all the information you need. Then instead of reading a data frame, we can also write it. So once we are, for example, we transformed some data entities in our data frame, then we would also like to be able to create a new data set and then store it as a CSV file. Now, in a similar way that we used PD read, we now have a data set that we read, and one of the functionalities within a Pandas data frame is that you can use the toCSV. And what this does, you can enter a path or directory. So what we say is we want to put in the folder outputs, we want to create a file out underscore small data.csv with separator given and a decimal character given. And what this does is if we write this, now in our directory within Google Drive, we have created a similar CSV file, but now in a different folder based on the data object that we had. Now, based on time, because I think we are a little bit behind, let's keep this, that you can just try this yourself after the session, and we will skip it. But basically, the idea is the same, and you can just try to run this, maybe try out some different paths and see where your file will be. Path or buff, this is just the parameter name. So yeah, you can just use any you like. So it's just to let the CSV function know where you want your CSV file stored.
There's a question, why do you use path or buffer rather than just path?
Yeah, so that's because we are mounting, and then yeah, it will work. If you're not mounting, then you can just use path, or don't even put anything in front of it. But for this reason, you can just also use file path or buffer. So it doesn't matter in the end.
Okay. There's another question. In this specific case, we replaced the original CSV file with the quote output underscore small data.sv.
Yeah, so now within your drive, if you go to outputs, now you will see out small data.csv. And we see at the time that I just created it. Does that answer your question? Yes.
Hopefully.
Okay. Well, then now for to give you some more examples, let's load another CSV file. So instead of data, we will call it df, and we will read from our data folder the example set new.csv. And once we have read it, we want to know yeah, what it will look like. So we use the head function to print the top 5 rows. And now we see we have a much larger data set with a lot of columns, yeah, and a lot of different data types. in order to get an idea on how large this data frame is, we can run the df.shape, and we see that we have 6,497 rows and 41 columns. So it's much larger than the examples that we just used. And to verify how many rows, it's still similar, we see indeed 6,497 rows. Now, within Python, it is also really good to know that you have a lot of different data types. So you have numerical data types, you have strings, and yeah, if you want, for example, want to multiply a string, it will work different than a numerical value. So it's also always good to know to get an understanding a bit on data types and if they are correct in your data set. So if you want just some idea about the data, about, for example, the missing values and the data types, what we can do is use the info function, so df.info, and if you run it for each column, we have the amount of non-null values, so that means that they are filled and not missing, and the data type, for example, an integer, so that's 1, 2, 3, 4, 5, object, and if you can see name, if we look at the data, we expect it to be a string because it's text, but within a pandas data frame, this will always be seen as an object if you read a string inside with read CSV. So it's also good to know that. Now we can also see, for example, that gender does not have the amount of non-null values as the other rows. So this also gives us an idea that for some people, for example, the gender value is missing. So the info function is good to play around with to get an idea on how many data is inside each column and how many data types are there. So yeah, in a similar way, if we go back to, so don't use df, but just use the small data. So data, please try to get a list of all the columns that we have in our data frame. That's going to be an assignment for 5 minutes. So please go ahead. I see that all already some of you are done, so let's give it another minute and then you can go ahead. I think most of you probably will already be done. So yeah, one easy way also to look at it is what I said with a dot and a tab. You can see what kind of options you have. And also one of the options is if we type here, we see columns. And then we get the columns. Yeah, so the reason why this doesn't have brackets is because columns is a value, so it's a stored value, and that's what like the index. And if we want to use a function, so something that performs an action like read the CSV, then we are using brackets, and that's that will be the difference between the two. Yeah, so this also one of the ways is indeed to use a for loop and then go through the list of columns. And the function, I see somebody mentioning in the chat, the function info. Don't really understand what you mean by that. But yeah, the easiest way to look at the data columns is to use just the column, dot columns, and then you get insights on what columns we have in our data frame. I see the question, why using data columns gives only object as type? Using info gives more data types. Yeah, so if you really want to specify the data types, yeah, then you use info. And what you can also do is to use data.dtypes in order to really only focus on the data type of your data. And then what we see is with data info, we get both the columns and the dtypes. But then if we solely use data.dtypes, we get the dtypes. The dtype is a data type. So I see the question in the chat that what's the difference between type and data type? The main difference is a type is really what Python uses, and such as an object. And a data type is the type that your data can have. So that can be integer, objects, date, format, etc. All right. Now, if we only want to focus on our numerical data types, what we can do is select dtypes, the function, and then include, for example, float 64. Float numbers are really numbers with decimal points. And what we can then do is just only select the columns that have this data type. And if we then print the head, so the top 3 rows, then what we see is indeed we get all the data where we only have numerical values with decimal points, so no integers. And what we can also do is exclude certain data types. So if we want to exclude instead of include, we can, for example, use the same function, but then exclude, for example, integers, and then we can check with the info function to see what data types we have in our data frame. And what we then see is only objects and floats and no integers. I see a question in the chat, what's the difference between float and float 64? Well, you also have difference in float types, and that's mainly the size of it. So if you know you're going to work with only small numbers, you're going to need less space. And then you can, for example, also choose float 32 and yeah, have less memory available for that. But yeah, I wouldn't recommend focusing on that. Just use it as a given, because then it will also get very complex very fast. So yeah, mainly just if you read a pandas data frame, it will automatically use float 64.
What about quote df dot select underscore d types parentheses include equal number?
Yeah, so well, if you just put in number, it won't understand. But later on, we will have an example where we can just use something with NumPy that bundles all the numbers, so you can just exclude or include numbers. And I also see a question in the chat. Double parentheses or single quotes, it doesn't really matter. It will be handled the same way. Yeah, so that's going to be an assignment for you. Yeah, we will handle it after this assignment, but that's also going to be the first question. Select all numeric columns of the data frame. So please try to figure that out, and then yeah, see if you can get the right answer. The rest of the questions, yeah, please just make them right now, and then we can discuss them afterwards.
So 10 minutes for this one?
Sorry?
How long for this assignment?
Yeah, let's try to take 5 minutes. We're running a bit behind, and then see how far you can get, and else we'll make them together.
Yeah, I was just wondering if I should have the breakout rooms again or not, but maybe it's
Yeah,
we'll save it for a longer one. Yeah.
Yeah.
You guys have finished this assignment, if you can raise your hand.
how many of you have their hands up right now?
11. 12.
Let's continue. We will discuss the answers. So if you don't have them, we can get them right now. So yeah, that it was already a question of one of you, but can you also just put in a number to make sure you, for example, select all the numeric values, and our package NumPy, which we imported as NP, has a like a bundle for number, which contains all the data types that are numeric. This can be used in order to select the data types that are all numeric. So yeah, if we put in NP number, then we get both integers and floats and all the data types that are numeric. So yeah, this way you can just select all numeric values. Now, if we want to take a look at which columns are numeric, just as you saw that we can use the columns in order to get the columns from the data frame object. If we first select on all the numbers, it makes a subset of the data with all the columns that are numeric. And then if we add dot columns behind it, yeah, we will get the columns that are numeric in this case. So the describe function is part of the Pandas data frame object. So in order to get some statistics on your data, what you can do is use the describe function on your data. And what it then does is gives for all your numeric columns, it will give a mean, a standard deviation, also the minimum, maximum, etc., and also a count. This can be helpful if you want to know within what bounds your data is and what the mean is of each column. However, if we force the describe function to include all data types, what we then get is that we also have the columns country and abbreviation part of it. However, as they are non-numeric, so we cannot take a mean or a standard deviation from, for example, names, those will be seen as missing values. So this gives a good example of why you, for example, only want to use numeric values, select numeric values if you want some data descriptions. Now, if we, another example, if we force all our data to be of the type string, so then we transform actually our numbers into text and then use describe and include all. Then also what we see is that we actually don't have a mean or a standard deviation even for our numeric values because we just transform them to a string type. And this is a good example of why you really should check the data types and could get into trouble when doing some data analysis if you don't check your data types on beforehand. So now the last one is, yeah, if we want to do a description without numbers, just as in the previous examples, instead of include, we can use exclude, and then on the NP numbers. So it will only show our non-numeric types. And what it then does is show the country and abbreviation for which we cannot take a mean standard deviation. So now let's, now that we have a bit of an understanding of data types and yeah, what it looks like, and getting descriptions of our data, now it would be also really useful to start looking at selecting columns in Pandas and making subsets of data. So within our data frame, a data frame consists out of multiple Pandas series. The difference is a Pandas series is just a single row or column. For example, just the column H. And a data frame is a bundle of multiple series, such that is a data frame with multiple columns or indexes. So I think that's a bit the most easiest way to understand the difference. And we can select this Pandas series by just filling out the column name between brackets. So if we, for example, want the column H, what we can do is we put our data frame here, and then between brackets put H, and set it equal to our H variable. And now if we print our H variable, what we see here is that we only get the values according this column, and we have all the rows here with all the values. So as I just explained, that a single column is actually a Pandas series. We can check that by here printing the data type of the variable, and now we use type again of the H variable. And what we see here, so it's not a data type, but it's really the type of our variable here. And what we see is that it's a Pandas series. So indeed, this is correct. Now this Pandas series is a different object than a Pandas data frame. So it has other functionality. However, most of the functionality regarding data transformations will all be the same. So if we, for example, use, oh wait, I need to set it here. So our H variable is equal to TFH. And now if we run the head function with the top 5, we see that we get a similar result, that we get the first 5 values of our Pandas series. So the functionality is pretty much the same regarding this. Instead of the head function, what we can also do with Pandas data frame objects and Pandas series is that we can slice them. So if we have a Pandas series, what we can do is put brackets behind them, and then put a slice with a double dot between them, and then we can give the index between which indexes we want to slice them. So for example, if we don't put anything here, it will start from the beginning, and it will go until the 5th row. So if we do that, we get the top 5 rows here. And we can also play around with it. So if, for example, we take 2 until 5, it's going to get different results. And with this, we can also make subsets of our Pandas series. If we want to take the last rows of a Pandas series, then instead of giving 2 numbers until a certain row, we can also put a minus sign in front of the number. And what this does is that we actually say we want the last 5 rows until the end row, until the last row. As you can see here, we have the bottom rows or the bottom values of our Pandas series. And also we can play around with this in order to get different results. So now we have the last 10 values of a Pandas series. Now, if we want to select multiple rows and columns, well, then we don't want to subset a Pandas series because that's only a single column. So what we then want to do is that we want to select from our data frame object that we have. So we read our data frame file, and what we want to do is, for example, get a subset of multiple columns. So let's say we want to subset age and gender. What we then can do is make a list with the column names and say our new df is equal to the df where we slice based on these columns. Then afterwards, we will print the top rows to see what kind of data frame we have. And if you run it, then indeed we see that we have a subset from age and gender. The two parentheses are because if you do a single split, for example, we put age here, then we split by a single column, and then it's a single. Then it's just a Pandas series, and then we only select the age. However, if we want to do multiple columns, the idea is to create a list which also begins with a bracket and ends with a bracket, and therefore we have double brackets. So I hope that gives an idea about the double brackets question. And here you can even see it better. So if we want to not only select certain columns, but also want to select certain indexes, what we can do is to use the log functionality. So what this does is we can put .log behind it, and then in a similar way the brackets. But then we have two options. First, we want to give all the index names that we want to select. And then we want to give all the column names that we want to select in a list. Log will really look at the name of your index and the name of your columns. So that's good to know. And if we run this, so we take a subset for the rows 5 until 15, and we select age and gender. And what we see is that indeed we get the index names 5 until 15 and age and gender. And also here we can play around with the subset that we take and also the column names that we use. I see a question here: do ilog and log behave the same way on rows? Well, they don't, but let me get an example. But that's exactly where we are headed right now. Is we also, besides log, have ilog. And what the difference between ilog and log is that ilog will look at the numerical index of your index and column, and log will really look at the values that you have there. So, for example, if we use ilog and we say we want place 0 until 10, and place 2 until the 8, and we run this, what it does, it will take the first 10 rows and the columns which are placed on the 2nd until 8 placed within our data frame. So it really looks at the amount of rows you want to have, and with log you really select the name of your index and the name of your columns. So that's a bit of the difference. We will get there also in your assignment. So here we have a little bit larger assignment again. So maybe it's good to split up in rooms again. And let's try to do this in 15 minutes. And here you can also play around. Make sure you use the data instead of df to for this assignment. And please try out if you can get the same results.
Also, just to let everyone know that I've enabled you to be able to share your screens now in the breakout room. Thanks, someone pointed out that was not enabled, so hopefully that'll also help. I'm gonna create the rooms and then open them up. Okay, everyone's back.
So yeah, everyone's back. All right, great. I hope you guys managed to get as much as the answers as possible. But let's go quickly through them. So just in the example, you can just put in for data, you can put in the string country as the column name and set it equal to country for. And if we print that, then we will get all the countries as a Pandas series. If we check the type of our country var, we can also see it is indeed a series. Now, if we want to make a more complex selection, so the first 3 rows and the country in abbreviation, so the 4 rows, what we can do then is use the log functionality to split until the index 3, and then we use the columns country and abbreviation, put it in, and then if we make a new variable country data, then we see that we actually have a subset of our full data frame. And if we check the type of that, then we can see that's a data frame instead of a Pandas series, just because it is a subset of a data frame and not just solely a column. In order to find out what you can do with the set index, I would recommend play around with it and indeed look at the parameters it has. Here are a lot of examples in what you can do with it, but let's not get too much into detail on that for now. But we want to try it. So what happens if we perform the function set index and we set it on the keys country, and we make it a variable data edx. And if we print that, then we see that our country column has disappeared. And right now, it has been transferred to the index. So first we had the numeric labels over there. So if we go back to data, we saw that we have numeric labels. And right now, because we have set the index to the country, now the labels are of a object type, which are the specific countries. And now I think you can also clearly more see why what the difference between log and ilog is. So the log functionality, we want to subset according to labels. So for example, France and Denmark. And then we want the columns abbreviation and X. And if we run that, first I need to run this one. What we then get is a subset of France and Denmark, purely based on giving the labels. And we can also do this for up till. So we take the Netherlands until the label Germany. So that's still the same as with the numeric versions of log. The difference is if we use ilog, we would really use numerical values to split the data frame up.
Sorry, Wim, one question.
Yeah.
If the column that you are using as a set index is not unique, will that make it fail? It should be unique, right?
Yeah. That's totally true. So it should be unique. So you cannot set a label if there are duplicate values. And yeah, you can use verify integrity with for that, because else you will get multiple rows if you select on Spain. So it is possible to have multiple. However, then it won't be. It's not recommended, because then if you, for example, select Spain, you can have multiple values for Spain. And that's not what you want. But in this case, it is fine. So now, if we also look at trying to get the country column out of our data ADX, we get an error. So we get key error. And that is because we set it as index. So once we set something as index and we remove it from our columns, it's not part of the columns anymore. And then we can also not use it to get a subset from it like this. However, if we look at the normal data set, we see it is part of the columns. However, if we look at the data IDX columns, we see it has disappeared. So that's also a difference. Now, if we look at the other functionalities that Pandas has, we see that we can do all kinds of transformations, such as sum and take the mean. So if we want to sum our column X, we can just do it. We can take the mean of data, the column Y. And yeah, by that, we can also get more statistics out of our data. And then the final two questions are Boolean type questions. So we haven't crossed that, but with Python, we have another data type that is called Boolean. And what you can do is you can set two equal signs next to each other. And we can, for example, say 10 is equal to 20. And what you then get as a returned value is false or true. Well, in this case, 10 is not equal to 20, so we get a false return statement. We can also do the opposite and use an exclamation mark and an equal sign to say 10 is not true to 20, and then we get that is true because it is not. The reason why this is part of in the assignment is that it's a bit of an introduction on the next part, conditional subsetting, because in the similar way that we can say 10 is equal to 20, that doesn't really make sense to use in Python. However, what we also can do is, for example, say our column H, we set it to 18, and what we then get as a returned value is a Pandas series full of statements, whether they are false or true. And within Python, true can also be seen as 1. So if we take, for example, the sum by using the NumPy functionality, we take the sum of this Pandas series where we say age is equal to 18. Then what we get is a return value of 40, which means that there are 14 people in this data set that have an age of 18. So that can be really helpful also to figure out things and to see how much people fall between certain buckets. We can, for example, also use this in a subset using log. So we can say df and then the log functionality. And then instead of giving index labels, we give a Pandas series with booleans. So age equal to 18. And then we say we want the columns, name, age, and gender, and then we want to print the top 3 rows. Now what we get is that we get a subset of our data, giving some people with the name and gender of the people that have the age of 18. So if you want to do some more exploring in your data, you can use this functionality to find out which people are within your data set and create subsets out of that.
There's a question in the chat.
Yeah.
Some parentheses data X works, but mean parentheses data Y doesn't. Why?
Sorry, can you repeat that? What works?
Yes, maybe I can plop it in the chat because it's in the
please put it in chat. Did you use NP? So if we go
before this part, can you please go up a little bit?
Yeah. So here.
Yes. So on the question 21, I just by curiosity, I tried some parenthesis data X.
Yeah.
Without NumPy, without NumPy, and it worked perfectly.
Yeah, so that is because you have the Python functionality of sum and mean. However, those are not meant for data frame objects. So if you want to, for example, take the sum of a list, 3 and 6, what you get is 9. However, it understands a list, but doesn't understand a Pandas data frame, and therefore it doesn't work. So yeah, I'll always use NumPy for that, or the Pandas sum or mean function.
Okay, thank you.
Yes. So yeah, once we have a subset of our data frame with people that have the age 18, and we have the columns selected, we can also print the shape again to see how many people do we actually have in this group. And if we look at that, yeah, we have 40 people and we have 3 columns selected. So there are 40 people in this data frame with age 18. Now, if you want to perform multiple equal statements, what we can do is, for example, say a data frame with the age less than 21 and somebody with the gender female. We can take the sum out of that, and what we get is that we have 82 people with the age less of 21 and a gender female. So if we put that in a log statement to really look at the data itself and not just the number, we can, in a similar way, type in df.log, then fill in the statement, and then the columns we want to view. And what we then get is the whole data set of all the people that have gender, female, and age less than 21. What is good to know is there are, if you want to create multiple Boolean statements, be aware of the parentheses, because if we would delete them, what we would get is that, yeah, it doesn't understand it, you will get errors. So always be aware of having brackets between your Boolean series if we want to add more equal statements to each other. So yeah, let's regarding the time, let's skip the assignment for now. You can after this session, you can also try these out yourself. So these are the let's also skip the missings part. Yeah, well, let's get into some statistics. So, for example, if we want to, if we have object type of data, such as names, but it can also be, for example, an income label regarding between 14 and 50,000. What we might want to do is to know how much of each label there is inside your data. What you can use for that is the function value counts. So if you have an object type, for example, we can also fill in gender here. Then you can get the counts of each of the values that are in your data. And by that, you can get an idea of yeah, how your data is distributed. If you're not interested in the counts, but just the unique values inside this object-based columns, what you can do is that get the unique function. And what it does, it will give you a list of all the unique values that are within your column, gender. What you can also get is the number of unique values. So if we want the number of unique values of age, what we can do is instead of the unique, you can put an n in front of it and look at the number of unique values. And we have 78 different values for this for the age in our data set. And similarly to yeah, the functionality as the mean and the sum, there are a lot of more data transformations that you can do, such as take the standard deviation or get the max value of your data set. I see a question, but if we type NP sum or NP mean, we do get results. What are these? Well, they are actually exactly the same results. So you have multiple ways of doing something. So if we type in NP mean or the NP max of age, then what we get is a similar number. The only difference is because this is a Pandas series object, it already has the functionality max from our Pandas library, and here we use the max function from the NumPy. Without the parentheses. Well, it is a function, so you should always do the parentheses behind them, because then it will try to find the maximum value and return it. Else you get the method of max, and that's not what you want. Well, based on time, let's get into a short summary of the aggregation of data frames. So now you've seen that you can create subsets of data and select certain indexes and columns. However, sometimes we also want to aggregate our data. For example, take the mean per country, or look at the maximum value per customer. And aggregating is in Python is pretty similar to SQL and can be done by using a data frame and then use the function group by. You can group by, for example, gender, and then use the aggregate where we say age we want to mean and the income we want to max. So it's very similar to a SQL statement where we select the average age as a mean age and the max income as a max income from a subset grouped by gender. So if we do this, so we take a subset gender, age, and income, and we look at the top rows. Now what we can do is that we group by gender and take the mean of our columns. So then what we get is indeed per gender what the average age is and what the average income is. And this way you can also get aggregations and transformations of your data set by certain groups within your data, which can be helpful. The aggregate function is if you want to use different functions for your aggregation. For example, for the age you want the mean and the income you want the max. What you can do is you can group by gender, and what we get is for the age the mean and for the income the max function. So yeah, if you want to take the mean for all your numeric columns, you can just use mean. However, if you want to have similar or different functions used in one data set, you can use the aggregate function. You can even do multiple functions for one column. So what you can, for example, do is give a list of transformation functions such as the mean and the median. And then what you can do, if you aggregate it, is that you, for the age, you get the mean and the median. So these are some examples of aggregation. I also see that it's already 4. So yeah, unfortunately, we did not really have enough time for the whole session. Luckily, there are answers after every assignment, just beneath all the assignments. So yeah, if you really enjoyed this session, then please go ahead and try to make them by yourself. If you do have any questions, you can also always email with questions, and I can also try to help.
Yeah, also would suggest to use the Slack channel for questions so that also everyone can see questions and work together. Thank you so much, Vim. I want to remind everyone to please take 2 minutes to fill in the form. Your feedback's really appreciated. Also, if you have any notes about the format, like using the breakout rooms, you can mention that in the comments as well. But otherwise, yeah, thank you so much, Vim, and have a great weekend, everyone.
Thank you very much.
Thank you.